Explain why alkyl groups act as electron donors when attached to a pi system. Very beautiful, very interesting question, and this is something which talks about a term called as hyperconjugation. The way it happens is this. See, if you have a C double bond C system, for example, let us consider propene. The simplest example is propene, CH3, CH double bond CH2. Now, I have a methyl group which is attached to a pi system. Is that fine? Yeah. Now, can I draw ethene first? Well, if you just care to draw the structure of ethene, I'm just trying to draw this in a plane, that's it. The way you visualize this is the plane of molecule, these are the sigma bonds. I'm just talking about ethene for the time being, and then there's a pi bond here. I mean, it's an overlap, fine and all that stuff. Some portion is below. I mean, this is above the plane, we can see it, it's below the plane, we can just see some part of it. That's how we visualize this. So this is the sigma bond, this is pi bond, this is C double bond C. Alright. Now, what they're saying is, if an alkyl group gets attached, so one of these hydrogens I'm going to replace by a methyl group. And let's see what happens. Let's say this one looks more spacious, so let me just change this. Say if this becomes C, H, 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 what happens? Please understand, if you visualize this methyl, can you visualize this as an umbrella? Umbrella, yeah. It's not a planar molecule. I mean, if one of these groups is on this, the second group would be protruding away in the direction of pen, and the third group would be actually pointing inward inside the board, which obviously I cannot poke my pen inside the board and show you. But then this is the way we denote it, by a cut line like this. I'll remove the earlier hydrogens. Yeah. So actually, the methyl group it's more like, just visualize my hand. It's like this. I mean, I have 5 fingers. There are only 3 groups. Imagine 2 fingers are missing, God forbid. But then, I mean, it's like this. And it's like a fan. So it's rotating always like this. So, although the fan has 3 blades or 4 blades, usually, if it rotates, what you see is roughly like a disc, right? In the same fashion, if this rotates like anything very quickly, I can't, this hand is bound, it's not free, I can rotate it, but if this keeps on rotating like this, then ultimately what you would see? You would be able to see this is something like a cone. It is more or less like a cone. So these bonds, because they are very quickly and happily rotating around this line. Oh my God, this got erased. Let me bring it back. Yeah, they're rotating like this. If it is rotating like this, so what I have is I have a cone of electrons. On this cone, hydrogen atoms are moving. And just like if a rotating fan, if you observe, you would be able to see something like a disc, although there is no actual disc. In the same fashion, when this fan-like structure rotates, you get a cone. And this cone has electrons, CH bonds. That means it contains those electrons, right? So electrons are on the surface of this cone. The bonds are on the surface of this cone. Please note that. And this electron cloud overlaps like this. Oh my God. That is the case. Yes, it overlaps like this. If you are doing it as per MO theory, molecular orbital theory, you could be actually more fashionable and you can say that pi star orbitals overlap this. Otherwise, in valence bond theory, you simply show that this kind of an overlap occurs. And because of this overlap, you find, and why does this happen? Why is it that, these electrons are attracted away from methyl group? It is because in methyl group, please note, CH3 is sp3 hybridized. And these are sp2 hybridized. sp2 hybridized carbon is more electronegative then sp3. Okay, very interesting. So you find that difference is small only, but these methyl groups tend to give away their electron cloud. The advantage being the electron cloud is now spread over larger volume. And the basic rule of chemistry is the greater the volume on which the charge is spread, more is the stability. So this, my dears, is also known as, well, if you want it in full glory and style, it is called sacrificial hyperconjugation. Let's cut the nonsense. Let's call it simply hyperconjugation. Yes, it is. And this is the way we write it. So that is the reason why alkyl groups act as electron donors when attached to a pi system.